Alright, this is unboxing the Rigol scope take 2. This is the replacement unit that was sent to me via UPS second day air to replace the defective unit that I showed last week. Second day air, it took about 20 hours for this package to get from the T equipment warehouse in Pennsylvania here to the city where I live, and it arrived here in the city where I live at, well, it was scanned at about 5:30 yesterday evening, and it was finally delivered to me at 9:45 today. So it's actually been in this town for much longer than it took to get to this town. It's been on the truck since about 7:45 this morning, and at least and I had to go outside. I was taking the dog for a walk, and I went outside, and the truck was halfway down the block. I don't know if he was trying to deliver it to a house down there or what. Last week they delivered it to the vacant house next door and just ran off. Alright, let's see what we got. We got a little bit of damage to the packaging. There's a puncture there and a pretty bad ding right there. And of course, dropped on a corner. Doesn't look like it was sealed up all that well either. So let's see what we got inside. What we got here? We got a power cord, that's good, and a package with a CD in it and an instruction book, one package of probes, USB cable, another package of probes, and Scoposcopy. They sure do package these things well. I'll give them that. Looks pretty good. There's no obvious damage through the bag. Oh, now I noticed something here. Rigol usually double boxes these things, but this was not double boxed. It's just a single box. That's kind of a fail, I think. It should have been double boxed. The last one that got here was double boxed. And there it is. Alright, take 2. Thank you for watching. Good morning, welcome to my laboratory. What you're looking at there is a little 16 megahertz crystal controlled oscillator with a CD74HCT04 inverter buffer chip. The crystal is making the chip oscillate at right about 16 megahertz. And I'm using this system to test and burn in the new replacement Rigol DS1054z oscilloscope. And what you're seeing there on the screen right now is the signal from one of the probes connected to the output of my little oscillator there. And I have the other probe connected up to the Philips PM6676 universal frequency counter, which has a crystal oven in it, so it's very precise and very accurate. It's the master instrument in the lab. And it's showing 15.992 kilohertz, so it's about 7.5 kilohertz off from the 16 megahertz nominal frequency of the crystal. So 15.992 or 993 megahertz is what's being shown there. And the scope's hardware frequency counter is showing 15.9927 against 15.992.6. So that's pretty darn close. The scope's hardware frequency counter agrees with the Philips. Now I'm going to put the camera in the tripod. Stand by. Okay, as you know, the previous scope had a bad glitch in the channel 4, so I had to send it back, and this is the replacement scope that T Equipment sent me very quickly. I sent the old scope back on the Monday morning and received the new scope on the Thursday night at 9:45, thanks to UPS second day error. Okay, so you're looking now at the channel 1 trace, and what I've been doing is testing each channel for the presence of glitches and stability. So here's the channel 3 probe that was connected to the frequency counter a moment ago, and now I'm going to plug it into the channel 3 input. Turn channel 3 on, and that's being displayed now at the same vertical scale, 2 volts per division, as the channel 1 trace, and we are in normal acquisition mode, auto memory depth, and to keep the traces nice and thin, I've got the intensity turned way down. If I turn the intensity up, you can see that the traces thicken. This is almost like blooming in an analog oscilloscope. So I've got the intensity turned down. There's a little intensity blip there, so that the traces are nice and thin, look well, like they're well focused. And the glitches in the other scope were occurring worst at 5 volts per division. So I'm going to turn the channel 4 to 5 volts, excuse me, 5 volts per division now. And then I'm going to go to the utility menu, PassFail, source, channel 3, range. Wait a second, what did I do here? Oh, PassFail on, range, create the mask, and now that creates the mask around the channel 3 trace. And then I select operate and stats display, and you can see that the statistics display is underneath the hardware frequency counter up there. So I'm going to turn that off. Measure, counter, off. And I'll just have the screen up now. So we're looking at the fall time of channel 1, the frequency of what's in the window, 16.0 megahertz, and the fall time of channel 2 on the measurements display there. And utility, PassFail on, operate. It's operating the PassFail system, and I have stop on fail on. So if the signal exceeds the range of the mask, then the scope will stop and any glitch will be preserved on the screen. And that's how I've been checking each individual channel for glitches. And there haven't been any. The scope has been perfectly stable and responding properly during this burn-in. I'm burned out, it's being burned in. Thanks for watching, and thanks to T-Equipment for being such a good vendor, and to Rigol for being a great company with great support. Thanks to Jason, who watched the previous video showing the glitches and who helped expedite the process of getting a replacement scope. I really appreciate the great service from Rigol and from T-Equipment. And so far, this one's checking out. Thank you for watching.